Hey everyone, welcome to today's webinar, Menardi's LD ePTF membrane versus standard ePTF membrane. I just want to go over a couple of notes before I turn it over to Dave. We have set aside time for questions after the presentation. Please look to the left of your screen and you'll see the Q&A box. And if you'll type those questions in during the presentation, we will get to them as soon as we can at the end and answer as many as possible as we can. If you have any problem with your audio, video, or any other technical issues, please comment in the Q&A section of the webinar screen or email me at christina.quick@menardifilters.com, and that's MENARDI filters with an S.com. You can also make the webinar screen full size by clicking the little 4 arrows in the upper right of your screen. And when the webinar begins, you can move the video box of the presenter that's on your right by simply clicking on it and dragging it into a new position if it interferes with any of your view of the slides. And now, without further delay, I'm going to introduce you to our presenter, Dave Thompson. Dave is our technical director here at Menardi, and he has over 39 years of experience in all aspects of the solid liquid separation business within the in-depth exposure in product and product management, sales and sales administration, engineering and product development, application engineering, and general management. He is truly an expert in both liquid and dry filtration. And so now, Dave, without any further delay, I'm going to turn this over to you.
Great. Thanks, Christy. Today we're going to talk about Menardi's new LD membrane, expanded PTFE membrane, and how it has more features and benefits than the standard expanded PTFE membranes on the market. Um, Menardi's LD membrane offers features and benefits that can give substantial cost savings for bag systems, whether they're pulse jet or reverse air. Basically, what it does is it reduces the drag across the filter media in the baghouse so that you operate more efficiently. And it does that by offering a filter media that has a very consistent pore size throughout and is a thicker, tougher membrane. So you have a very a verifiable pore size and more pores. So you get a very high porometer and very good porosity and airflow through the media. So to start off, we're going to talk about filter drag. Okay, and this is what this media does. It reduces the total resistance of airflow in the baghouse created by the filter media and the dust in the system. Standard systems will have an operating an air permeability, clean differential pressure somewhere around 2 inches. And with the low drag membrane, it's a little bit higher. It's somewhere around 4 inches. But what happens with the low drag membrane is because it's so consistent, it flattens out. Standard membranes, because of the inconsistency in them, they don't flatten out, and the differential pressure continues to escalate until you get to a point where you've got to obviously back pulse or reverse air, take the system offline and clean the bags in the case of a reverse air system. So what we try to do with our LD membrane is to conserve energy by operating your fans more efficiently, producing less compressed air, so you don't because you don't have to do back pulses frequently, and then saving overall cost in the unit by reducing energy costs. So and in the end, reducing the wear on the bags, because typically most bags wear out from the inside just from pulsing or over pulsing. Um, the low drag membrane does several things. It um, helps to keep all of the media, all of the particulate that hits the surface of the filter bag on on the membrane. It does not allow for penetration of it because the pore sizes are 3 micron pore size, very fine, and therefore the majority or the predominance of the material is captured on the surface of the media, not allowing it to get into the deep matrix or the tortuous path of the media and making it easier to back pulse off. It's a thicker, more robust membrane, so it can take the higher pressures, differential pressure, and it can pulse under standard, up to 90 pounds, 110 pounds of compressed air to clean them. It's a very consistent pore structure that makes it very easy to clean repeatedly, versus the old type of membrane, which had a very inconsistent surface and pore structure, in that it allowed particulate to penetrate into the deep matrix of the material and the tortuous path, get stuck in there, and over time, as the media was pulsed and cleaned and then brought back online again, more small particulate would get trapped, and eventually the differential pressure would rise. The run times would be, the duration between pulses would be shorter, and you would end up pulsing more frequently, thus creating more stress on the media and begin to wear the bags from the inside out. Plus, over time, that differential pressure would become untenable, so we'd have to eventually change the bag sooner. With low drag, we reduce all of those things, the probability of material getting into the tortuous path, the need for more frequent pulsing, and extending the time between those pulses, and therefore extending the life of the bag, and getting a much more efficient pulse that gives you a very, very defined cutoff point and helps you stay within your permit limits. Um, Traditional ePTFE membranes are like low drag or LD membrane are surface membranes. However, because the surface is inconsistent, you get some entrapment of fine particulate. You do get good cake release off of traditional membranes. There's no doubt about it. Versus a regular bag with a dust cake on it, you do get very, very good cake release and good cleaning. However, not as good as you would with the low drag. The low drag offers a low differential pressure offers a slightly higher differential pressure at the beginning, but then it flattens out. In regular membranes, you start off with a lower DP, that's for sure, but that differential pressure increases and will keep increasing. Um, Relative to regular bags, you do get an extended life from a membrane type bag, but not the kind of life that you can get from a low drag bag. So um, typically most membranes handle upset conditions quite well, so that you don't have the catastrophic failure that you would have in normal bags, typically with membrane type bags. Um, if you look at the in this slide, the photo on the left that shows the Menardi LD membrane under microscopic photograph, you can see that the membrane is much more consistent. It's a membrane that will, because of that consistency, offers repeatable performance cycle after cycle after cycle. So, and because the pore size is reduced versus the traditional on the right, which you see is really more of a random pore size. It may average out at something around, well, we say that on standard ePTFE membrane, you've got your capture efficiency of 99.98% at 2 micron and above. You get that with the low drag as well. However, the low drag handles the finer particulate even better. So it can capture more fine particulate on the surface and back pulse it off. So when you compare the two, we say here there's a cost savings of, we say, $160,000 a year based on a standard large baghouse, whether it's pulse jet or reverse air for electric arc furnace applications. This is the same holds true for in the cement industry, in the carbon black industry, and in several other areas where we've been using them now. Menardi now has our low LD membrane installed in all of these industries: electric arc furnace, and carbon black, in cement plants, and in other applications where we're trialing it right now. We're trialing it in oil and gas right now. And so we've got it in several different areas where it has performed quite well and has outperformed what our old standard membrane and our competitor standard membrane. So it's been a net positive for all of our customers in that they're getting longer duration between run cycles, they're getting better cleaning, and they're getting a flattened out lower differential pressure overall that makes the bags last longer and gives them better wear resistance. Um, Again, if you look at the graph, the dust cake formation begins and stays on the surface. It's a tight, consistent pore structure that leads to excellent cake shedding. So it really works quite well and can handle the aggressive environments that you find in some of these different applications. again, the concept of the Menardi LD is based upon a heavier, tougher membrane, which allows minimal dust cake to get into the deep matrix or the tortuous path of the media. Um, Again, you can see from the image on the left a true surface filtration of the low drag, and the image on the right of the embedded particulate on a standard traditional membrane. Um, this ties into what we talked about in our last webinar, which was low total cost of ownership, and this helps you to reduce the cost of total cost of ownership of your bag house. You know, bags that are fabricated from using low drag membrane or LD membrane are more expensive. There's no doubt about it. There's probably a 20% upcharge on the price per bag. But in what you save in uh, energy consumed to run your fans, you can run your, especially variable frequency fans. You can run them at lower fan speeds. You get uh, a cost savings on the energy used to push the air across the bags, and then you get an energy savings on the compressed air required to clean um, the bags when they reach a differential pressure. So because you clean less frequently, you're saving money on both. You have a lower drag while you're running the bag, and then you have less compressed air used because you're pulsing less frequently. All that adds up to a cost savings of probably in the end, 15 to 20% on the overall cost of running the baghouse. Um, if you look down at the graph, you'll see the standard felt. Um, it starts off. Um, with an air permeability before it's been seasoned between 25 and 45 CFM. That then, once you've seasoned that bag, you reduce that down to somewhere around 2 or 3 CFM, and that is it's only operating at about 8% of its capacity. Whereas on the other end of the scale, the low drag's operating at plus 75%. So it's really a highly efficient material that saves cost over the long run. Um, in pulse jet and reverse air systems. Here's some more photographs of the surface of different types of membranes. These are traditional expanded PTFE membranes that show the membrane without any particulate on it, and then on the left and then on the right it shows the membrane with particulate and shows how it becomes embedded in the membrane. So what you're seeing on the top surface on the photos on the right is embedded particulate in the membrane on the surface of a standard expanded PTFE membrane. And that makes it really tough to get off. It's very difficult to get off. So because of the random nature of the pore structure, and you can see that on the left in both photos, that you will get particulate being embedded, and it gets very, very tough to remove. And over time, that goes up. That blinding of the media can become at times, especially in upset conditions, exponential, and it can really cause a catastrophic failure, and the bags will need to be changed, or you'll reach a terminal differential pressure much faster than you normally would in a system where you're cleaning the bags 100% with each pulse cycle. So the old type of membrane, because it is so random, it is just a lot less efficient. What you're seeing below the membrane is just the fiber from the needle punch felt that typically these are put on. But we can put them on anything. We put them on wovens, we put them on non-wovens, and and all different types of media, from polypropylene, polyester, glass, Rayton, and so forth. Um, so with the RLD, we have true surface filtration. We have excellent cake release. We have a very low pressure drop. We have a longer filter life, and we have recovery from upset conditions. Because the membrane doesn't allow the smaller particulate to embed itself in the media, upset conditions are few and far between. Not that they don't happen, but they're less likely to happen. Upset conditions can happen in anything, as we all know. So you're getting a material that will capture the media, the dirt, on its surface and pulse it off efficiently. Uh, Truly a clean pulse. Uh, the features and benefits again of this are superior performance thorough cake release during the cleaning cycles, a consistent delta P after each cleaning cycle. So the differential pressure increases to 6-7 pounds, and then it is pulsed off, and it goes right back down to the 4 that it starts at. Um, it stays there for a long period of time. It levels off, right? Unlike regular membranes, that the differential pressure continues to increase throughout the its cycle. Lower operating costs. You get a higher throughput rate. You can push more through, or you can run your fans lower and still get the same kind of throughput you're looking for. It actually gives you the ability to operate at slightly higher flow rates if you need to, without stressing the filter media. And again, the operating delta P starts slightly higher but flattens out. It's a lower maintenance cost. You have less frequent changeouts. You have more uptime between cycles, available use of the media, and then you have longer overall life. And then they're less expensive than other membranes in the long run because you're changing them less often and you're using less energy to operate them, both with incoming air and with pulse, the consumption of compressed air for pulsing and cleaning. That's what we've got right now. If there's any questions, we'd be happy to take them from you right now. And
Thanks, Dave. I do have a few questions that have come in. If anyone else has a question, please use the Q&A module to the left, and we will get to them momentarily. So the first question, Dave, is from Derek. What are the actual savings that can be gotten from using Menardi LD membrane?
again, the you will see, and some people see, I won't call it sticker shock, but they'll see a higher price when we price LD membrane as an alternate versus regular membrane. But in the end, that higher price is balanced off by and basically negated by the cost and savings of compressed air and horsepower required to run your fans. So there are savings all the way around. So you do spend a little more money for the bag, 15 to 20% more per bag up front, but that savings is brought back on the backside because the bags, you're not changing them as frequently, and you're using less horsepower and energy to run your fans and to produce compressed air and pulse more often, or you're pulsing less. So that's where your cost savings are gained, and they're measurable. We have data we can show people on that all day long. Oh, does that help? Hopefully that answers the question. Any other questions, Chrissy?
Yes, Dave, thanks. One from Charles. Can Menardi LD membrane be used in all types of baghouses?
Yeah, we have it in place like as I mentioned in oil and gas right now, petrochemical process. We have it in carbon black. We have it in the cement industry, and we have it in the uh, steel production. So it works well in all of them. And in each one of those applications, we have the membrane on a different type of substrate. In the oil and gas, we've got the LD membrane on a Teflon felt substrate, and in others we have the LD membrane on glass. So and on polyester felt. So we can put it on all different types of substrates, and it operates well in many different applications, regardless of the condition, relative to aggressive nature of the if it's high sulfur content, or if it's a very acidic or a very caustic application. It works well in all those.
Okay, looks like we have one more question, Dave, from Stephen. Can standard cages be used with Menardi LD membrane, or is there a cage design that works better for this type of bag?
So as we all know, typically, in standard polyester felt, polypropylene felt, Riton felt, you can use a standard cage. Standard cages are no problem. But when you get into all Teflon felt with the expanded PTFE membrane or glass, you need to go to a heavier cage just to reduce the wear and the movement of the media, so you don't get the wearing that you typically get. But no, they're not out of this. They're the cages that what we use for in applications where we use the LD membrane are standard cages for that particular filter media. They're standard. There's nothing special about them. That you don't have to go out and buy new cages typically for your application. The cages that you use, of course, we always recommend changing cages between change out if necessary or when necessary. But no, standard cages can be used.
Okay, Dave, we have just another question that came in from Jonathan. How do you estimate the reduction in pressure drop along the bag life?
So what we do, because we know that this media starts off at a little slightly higher differential pressure, it can be a little deceiving. It starts off at a higher differential pressure, but because of the uniform nature and because the dirt is being captured on the surface, it truly is, it's what is known as dirty bag technology. It's almost like you've got a dust cake built up on the bag already, as most membranes are like that. But this one's even better than that, the LD membrane, in that it acts like a true, like it's got a true dust cake on it, so you can continue to operate and continue to push, um, you know, particulate laden air across these for a long time, much longer than standard bags, because the differential pressure flattens out. It does not continue to escalate. You won't see differential pressures of 9, 10, 12 psi inches. They're gonna it's gonna start at 4 and probably flatten out around 6 or 7, and you can run that way for quite a while. So the run times between pulses, the duration is longer, and it's easier to pulse it off. So we just know through data that we've taken, and we can show data that show that exhibits the flow patterns and the differential pressure. Um, well, for lack of a better term, accumulation of differential pressure over time is longer than on standard bags, because it is such a uniform surface, and it allows for um, greater um, flow rate under higher differential pressure situations.
Okay, does it I think that's all of the questions that we have in our Q&A section right now, Dave. So Um, thank you guys for your time today. And as a reminder, we'll be sending out a recording of this webinar shortly. And if your questions were not answered, or you don't feel free in typing in the Q&A, you can reach out to us privately um, through your email to me that I gave you, or through our website. And a Menardi representative will be with you shortly, hopefully in 24 hours, to answer any questions that you may have. And also at the end of the webinar, you'll have some poll questions. Please answer those. They help us tremendously with any feedback that we get on how we can improve. And like I mentioned earlier, you can always visit our website for more information at menardifilters.com. And I thank you, and we look forward to working with you guys in the future.